Hi and welcome. In this video, we're going to introduce the Phillips curve, which is chapter 8 of our macroeconomics 2 module. So the Phillips curve basically looks at the relationship between unemployment and inflation. So the Phillips curve was introduced by A.W. Phillips in 1958. So A.W. Phillips drew a diagram plotting the rate of inflation against the rate of unemployment in the United Kingdom for each year from 1861 to 1957. He found a clear evidence of a negative relationship between inflation and unemployment. So this means that when unemployment was low, inflation was high, and when unemployment was high, inflation was low or often negative. So the policy implication of these findings was that countries can choose between different combinations of inflation and unemployment, such that when they wanted a high inflation, they should be willing to take or accept lower unemployment. And when they wanted lower unemployment, they should be willing to accept high inflation. However, during the 1970s, the relationship between the two variables disappeared. So this showed both high unemployment and inflation. So the curve became between the rate of unemployment and the change in inflation rate. So this was a new relationship. So instead of a relationship between unemployment and inflation rate, it was one between unemployment rate and the change in inflation rate. So 2 years after Phillips developed the Phillips curve, two economists from the United States duplicated it to see the relationship between these two variables in the United States. That was Paul Samuelson and Robert Solow. So they developed one in between the years 1900 to 1960. So the results of that study is shown in this graph. So apart from the period of very high unemployment during the 1930s, there also appears to be a negative relationship between inflation and unemployment rate in the United States. So this relationship, which Samuelson and Solow labeled the Phillips curve, rapidly became a central macroeconomic thinking and policy. It appears to imply that countries can choose between different combinations of unemployment and inflation. So a country could achieve a low unemployment if it were willing to tolerate a high inflation, or it could achieve a price level stability, that is zero inflation, if it were willing to tolerate higher unemployment. So since the relationship between unemployment and inflation broke down around the 1970s, the purpose of this chapter is to explore the mutations of the Phillips curve and more generally to understand the relationship between inflation and unemployment. The first step is to show that the aggregate supply relation can be written as a relation between inflation, expected inflation, and unemployment rate. So the aggregate supply relation that we developed in chapter 7 is given by this equation here. It tells us that price is a function of expected price, and it's also a function of markup, unemployment, and the catch-all variables. So if you remember very well, the function f here in the aggregate supply relation captures the effect of unemployment rate and the catch-all variables on wages. So the M there is the markup of price over wages. So for our convenience here, let's assume a specific form for the function, for the F function that is given by this equation. So this basically tells us that the function of unemployment rate in Z can also be given by 1 minus alpha unemployment plus the catch-all variables. So this equation basically captures the notion that the higher the unemployment rate, the lower the wages. And the higher the catch-all variable Z, the higher the wages. So the new parameter now there, which is alpha in lowercase alpha in Greek, captures the strength of the effect of unemployment on the wages. So now if we replace the function F by this specific form in the aggregate supply relation, the equation we're going to get is this one. So instead of F of unemployment and catch-all variables, we use 1 minus alpha of unemployment plus catch-all variable Z. Okay, so finally, let's let this symbol known as pi represent or denote inflation rate, such that expected inflation rate will be represented by a pi with an expectation symbol. So then the new equation given this is given by this equation here. So let's label this equation 8.1 and that equation 8.2. So deriving equation 8.2 from 8.1 is not difficult, but it is tedious, so we'll skip it for simplicity's sake, and its explanation will be provided in the appendix at the end of the chapter. What is important is to understand each of the effects at work in this equation. So an increase in expected inflation, this one, leads to an increase in actual inflation. This stems from the relationship between price and expected price in the AS relation. That said, an increase in expected price will lead to an increase in actual price level. Also, given expected inflation, an increase in markup or an increase in the catch-all variable Z lead to an increase in inflation, in the inflation rate. This explanation can also stem, or rather it also stems from the AS relation, in that given expected price level, an increase in markup and the catch-all variable Z increases the price level. So this argument can also be used to support the relationship between the expected inflation and markup and the catch-all variables. Okay, and again, given expected inflation, an increase in the unemployment rate leads to a decrease in inflation, as shown by the negative sign here. So from the AS relation, given expected price, an increase in unemployment rates leads to lower wages, which leads to lower price level. So we can conclude on this new equation. So the new equation tells us that an increase in expected price inflation leads to an increase in actual inflation. 2, an increase in markup or other factors of wages determination Z causes an increase in inflation. Lastly, an increase in unemployment rate leads to a decrease in inflation rate. So the last step before returning to discussing the Phillips curve is to add time indexes to the equation. So when we look at the movement in inflation and unemployment in the rest of this chapter, it will often be convenient to use time indexes so that we can refer to variables like inflation or expected inflation or unemployment rate in a specific time. So we write the equation with a substructure of T such that this pi T represents inflation and that represents expected inflation and unemployment in year T. So the T will represent a certain year. So be sure to see that there are no time indexes in the markup and the catch-all variable Z. This is because we shall typically think that the M and Z are constant while we look at the movements in inflation, expected inflation, and unemployment over time, since this is basically the relationship we are interested in. Let's start with the relationship between unemployment and inflation as it was first discovered by Phillips, Samuelson, and Solow around the 1960s. So imagine an economy where inflation is positive in some years, negative in others, and is equals to 0 on average. So note this is not the way things have been for some time. Since the 1960s, inflation has been generally positive, and it has been consistent over time. So in an economy where inflation is positive some years, negative in others, and on average is equals to 0, how will wage setters then choose nominal wages? That is the nominal wages for the coming years. So with the inflation averaging at 0, it is reasonable for wage setters to expect that inflation will be 0 over the next year as well. So therefore, we assume that our expected inflation is equals to 0. So when this is the case, then inflation will be given by, or rather the equation will show a negative relationship between inflation and unemployment rate. So this is precisely the negative relationship between inflation and unemployment found for the UK and US by Phillips and Solow and Samuelson. So the story behind this relation is simple. So given the expected price level, which workers simply take to be the last year's price level, lower unemployment rate leads to higher nominal wages, and the higher nominal wage leads to higher price level. So putting the steps together, we can say that lower unemployment leads to higher price level this year relative to last year's price level. That is higher inflation. So this mechanism is also known as the wage price spiral. And the process is as follows. So lower unemployment leads to higher nominal wage. In response to the higher nominal wage, firms increase their prices. The price level increases. In response to the higher price level, workers ask for higher nominal wage the next time the wage is set. So the higher the nominal wage leads to firms to further increase their prices. As a result, the price level increases further. And in response to further price increases, workers, when they set wages, ask for higher nominal wages. And so the race between price and nominal wages result in a steady wage and price inflation over time. All right, this is the end of our first part. Thank you.